Hello everyone, we are from Group 3 going to present our mini project named Smart Crowd Control. Before we proceed to our demonstration, I would like to mention some of the components that we have used to make this project successful. For the first one, we have used two PIR sensor for the entrance and exit, as you can see over here. And then we also have used servo motor to make the barrier gate. Also, there will be 3 LED lights which are red, yellow and green, and then 3 7 segments over here, and then FPGA to program the circuit. And also this is the circuit that we have used to build this project.
Okay, now let's start off the demonstration. So there are 3 7 segments here. Namely, this one is the entrance entrance 7 segment, which shows the number of people entering the building. This one is the occupancy 7 segment. It shows the number of people inside the building, and this is the exit 7 segment. It shows the number of people exiting the 7 segment. So as you can see, as I put my hand through the entrance sensor, it changes to 1. The 7 segment showing the entrance shows 1, and the occupancy also shows 1. So as I keep on putting one by one, the 7 segment increases in number. Okay. As it reaches 6, the entry reaches 6 and the occupancy also reaches 6, the yellow LED bulb lights up, indicating there's only one more entry inside the building. As you can see, the entry number also showing 6 and the occupancy 7 segment is also showing 6. So if I have one more entry inside the building, as you can see, the entry limit is reached, which is 7, and the occupancy limit is also reached 7. So the LED bulb red indicating there will be no more entry and there's no more people allowed in the building lights up. So as the maximum number of number is reached, which is indicated by the red light bulb, the barrier gate is closed manually by using servo motor. Okay. After checking out the exit sensor and how the barrier gate works when there's a full occupancy inside the building, let's check out the exit 7 segment and how the exit sensor works. So if the exit sensor senses any motion, the 7 segment of the exit sensor shows 1, indicating there's still one more entry inside the building, as the occupancy segment shows 6, and the barrier gate is manually moved up again for one more entry. As you can see, we continue to have motion sense in the exit sensor, and it indicates 2, and it keeps getting up as it keeps sensing any motion. And therefore, for each and every count after the exit sensor, LED green lights up, indicating there's more and more occupancy inside the building.
So for the software part, we use Quarters to program our circuit and upload it to the FPGA board. And I will explain about the details of the software circuit in the next video. Assalamualaikum and good day everyone. So now I'm going to explain the detail about the circuit that we built in Quarters. So here we got 2 synchronized counter, 1 subtractor and 3 decoder. So let me explain the first part of the synchronous counter here. So the synchronous counter here, it will be triggered when a person uh, pass through the PIR sensor, and the PIR sensor is here. When a person pass through the PIR sensor, the uh, the synchronous counter will be triggered, and the output will be passed to the decoder here. The decoder here will be display how many people go into the specific building. And for the second part of the synchronous counter here, will be represent how many people come out from the building. And this is the PIR sensor that will trigger the synchronous counter. So as you can see here, we got subtractor here. The subtractor here is we built from adder. So after making some research online, we found that it is possible to build subtractor from adder. So as you can see here, we add 3 exclusive OR gate here and 3 NOT gate from the output of the full adder. So after both of these, both of the synchronous counter output come to the subtractor here, the subtractor output will pass to the last decoder here to represent it, and the decoder will pass to the 7th segment to display how many people left are in the building. So if as you can see here, the output of the subtractor will be passed to this logic gate here. The logic gate here is to represent how many people are left in the building. If the green LED is light up, represent there is 1 to 5 people, 1 to 5 space are available inside the building. If a yellow if a yellow LED is light up, it will mean that it is only left 1 space for a person to enter a building. So if a red LED light up, represent that the building is full. So how do we make this logic gate here is by using the Boolean expression. And after we make the Boolean expression here, we will kmat it, and then we got this. And then that is all for my part. Thank you.
Hello everyone, now we are going to discuss the hardware part of our project. So let's check it out. So let's check now. For the first part, we use servo motor with the 555 timer. So as you guys can see, this is the circuit that we have used to make this servo controller circuit. So initially we decided to use servo motor to make barrier gate in our project, so that the barrier gate will close when the counter hits 7. So we manually do it. So the servo motors are controlled by pulse width modulation signal as their input. The position of the servo arm depends on the width on which is high pulse of the input PWM signal. If you set the width of on time to 1 millisecond, the servo arm moves to 0 degree position. If you set the on time to 3 milliseconds, the servo arm moves to 100 degree position. The width of time low pulse is maintained at constant at around 18 milliseconds. And then for the next one, to detect the presence of the motion, we use PIR sensor. So basically a PIR sensor is a passive infrared sensor, is a device that detects the presence of warm object such as human or animal by sensing changes in infrared radiation levels within its field of view. And then the output pin of PIR sensor, so there were 3 pins, which is VCC, V out and ground. The ground connected to ground, the VCC used to power up the PIR sensor, and then the output pin would typically be connected to the clock input of the counter IC, which we made using FPGA, so that every time the sensor detects the motion, it triggers the next count on the counter. And it's important to confirm that sensor's voltage level is compatible with the counter's IC voltage level also. And then for the next one, we use 3 LEDs as hardware for our project, which are LED green color, LED yellow color, and LED red color. So we use LED to indicate the level of crowd in our project. Let's say if there were 1 to 5 people inside the place, it will light up the green, which is the people still can enter the place. And then if the counter hits 6, uh, the yellow color LED will light up, which indicates that the place is going to almost full. And then the red color, which indicates when the place already full already. So that's it.